Now let's solve one more question. Show that the function f of x given by f of x is equal to e to power 1 upon x minus 1 upon e raised to power 1 upon x plus 1 when x is not equal to 0 and f of x is equal to 0 when x is equal to 0 is discontinuous at x equal to 0. By now you know it very well that a function will be discontinuous at a point if and only either its limit doesn't exist or it is not equal to the value of the function at that point. So let's first of all check whether the limit of this function at the point x equal to 0 exists or not. And for that, let's find out its left-hand limit. Now left-hand limit of this function at x equal to 0 is equal to limit x approaches 0 from the left-hand side f of x. And now if we write x as equal to 0 minus h, then in that case when x approaches 0, then in that case h will also approach to 0. So that means this limit can be also written as limit h approaches 0 f of 0 minus h, and which is equal to limit h approaches 0 f of minus h. And now putting the value of minus h in the function f of x, then this limit becomes limit h approaches 0 e raised to the power minus 1 upon h minus 1 divided by e raised to the power minus 1 upon h plus 1. And after further expanding this expression, limit h approaches 0 1 upon e raised to the power 1 upon h minus 1 divided by 1 upon e raised to the power 1 upon h plus 1. Now, what will be the value of limit h approaches 0 1 upon e raised to the power 1 upon h? Now when h approaches 0, then in that case 1 upon h will approach to a very big number, or you can say infinity. And e raised to the power infinity is also equal to infinity. And 1 divided by big number infinity is equal to 0. So that means the limit h approaches 0 1 upon e raised to the power 1 upon h is also equal to 0. So now this limit becomes 0 minus 1 upon 0 plus 1, and which is equal to minus 1. And now let's find out the right hand limit at x equal to 0. Now limit x approaches 0 from the right hand side f of x is equal to limit h approaches 0 f of 0 plus h, where x is equal to 0 plus h, and which is further equal to limit h approaches 0 f of h. Now putting the value of h in the function f of x, then this limit becomes limit h approaches 0 e raised to the power 1 upon h minus 1 upon e raised to the power 1 upon h plus 1. And now dividing both numerator and the denominator by e raised to the power 1 upon h, then this limit becomes limit h approaches 0 1 minus 1 upon e raised to the power 1 upon h upon 1 plus 1 upon e raised to the power 1 upon h. And we have already proved that limit h approaches 0 1 upon e raised to the power 1 upon h is equal to 0. So that means this expression now becomes 1 minus 0 upon 1 plus 0, and which is equal to 1. So now the left hand limit is equal to minus 1 and right hand limit is equal to 1. So that means the left hand limit is not equal to the right hand limit, or that means the left hand limit and the right hand limit do not coincide at x equal to 0. Or in other words, the function f of x is not continuous at x equal to 0, or the function f of x is discontinuous at x equal to 0. Now let's solve one more question. Check the continuity of the function f of x, and the f of x is given by f of x is equal to cos x upon half pi minus x if x is not equal to half pi, and f of x is equal to 1 when x is equal to half pi. And here we have to check the continuity at the point x equal to half pi. You know it very well that a function is continuous at a point if and only the value of the function at that point is equal to the limit of the function at that point. And now what's the value of the function at the point x equal to half pi? Now as per the definition of the function f of x, we are given that f of x is equal to 1 when x is equal to half pi. That means f of half pi is equal to 1. And now let's find out the limit of the function f of x at the point half pi. And for that, let's first find its left hand limit and then the right hand limit. Now left hand limit at x equal to half pi is equal to limit x approaches half pi from the left hand side f of x. Now suppose x is equal to half pi minus h. And now when x approaches half pi, then in that case h will approach to 0. So that means this limit can be also written as limit h approaches 0 f of half pi minus h, and as per the definition of the function, this is equal to limit h approaches 0 cos of half pi minus h upon half pi minus h. Now cos half pi minus h is equal to sin h. So now this limit becomes limit h approaches 0 sin h upon h, and in the previous classes you have already learned that limit h approaches 0 sin of h upon h is equal to 1. So which means here the left hand limit is equal to 1. And now let's find out its right hand limit, and the right hand limit at x approaches half pi is equal to limit x approaches half pi from the right hand side f of x, and which is equal to, and again if we put x as equal to half pi plus h, then in that case when x approaches half pi, then in that case h approaches 0. So now limits becomes limit h approaches 0 f of half pi plus h, and which is equal to limit h approaches 0 cosine of half pi plus h divided by half pi minus half pi plus h. And cos of half pi plus theta is equal to minus sine theta. So that means this limit can be also written as limit h approaches 0 minus sine h upon, now half pi minus half pi plus h is equal to minus h. So this is equal to minus sine h upon minus h, and which is finally equal to limit h approaches 0 sin h upon h, and which is equal to 1. So now the left hand limit, right hand limit, and the value of the function at the point half pi are all equal to 1, and which means the limit of the function at the point x equal to half pi is equal to value of the function f of x at x equal to half pi. And as per the definition of continuity, a function is continuous at a point if its limit exists and is equal to value of the function at that point. So that means the given function f of x is continuous at x equal to half pi.